Okay, we've got some problems here. I'll just observe for the record that, this problem is one that is associated with the assignment before last. This is the one that's that's associated with the assignment, okay? And almost everybody's pretty much having trouble with this one, and some people are having trouble with this. This means you need to go back and review, okay? You really need to do that because this is pretty simple, okay? Pretty important, and we need to move through it. So, and it's not, don't feel badly about that if you do need a review. I'll email you with some advice on how to take some notes on what you do so that you can summarize it so you see what the procedure is. I'll also give a little more attention to giving you just explicit procedures. Okay? Here's a set of rules. Here's what you do. Here's what you do. Here's what you do when you see this, that, or the other thing. Okay? Now, you need to learn to do that for yourself. Not that I mind doing it. Okay? I'm fine with doing it. But it's too much for me to expect you to be good at doing that at this point in your education, in your math education. Okay? So I'm going to try to help you along with that. So you'll see kind of what I'm doing as we go through these problems. All right. Let me do one more thing. Don't want the stuff that I wrote up here to distract you. So with that blank board in behind there, move this board over here and you won't have to read all the stuff. Okay. Okay, so first problem, find the equation of the line y-intercept at 0,5 containing the point 49. Okay. Now, you all did, everybody I think sketched a graph. Okay. Some of the graphs could have used a little more detail. Most of them actually could use a little more detail. So I'm going to get the graph here representing this problem. Because here's your y-intercept. That's the 0.05. I would really like to see you. I don't necessarily require it, but you're going to be better off if you sketch the line y equals 5. You agree that every point on this line, if this point is 0,5, of course I would represent this point, then every point on this horizontal line will also have y coordinate 5, right? Okay. This just helps you get better at thinking in terms of the graphs and what they mean in the coordinate system, because the coordinate system is new to some of you, and it's still a little bit shaky for some others, okay? You want to get really good with the coordinate system. This is something that I try to emphasize in my pre-calculus classes. It's something you kind of assume when people come into pre-calculus because it's a big part of intermediate algebra. And open math doesn't really have a good alternative. They give you a grid. So the grid's already there and all the coordinates are labeled and you never have to really do it. Which is why I think I talked last time about why you need to draw graphs. And I'm pretty sure I talked about it last time because everybody seems to be doing graphs. You need to get a little more detail in your graphs. And that's one detail that I really want to see. Okay. If you have this, it's going to make it easier to see what's going on and what other things you need to concern yourself with. Okay. So now we do the 0.49. Okay, where's the 0.49? Well, y is equal to 9, right? And x is equal to 4. Well, we sketch a line for y equals 9. Now 5's here, then 10 will be here, so 9 will be maybe about here. And your graph doesn't have to be totally accurate. It doesn't hurt to make reasonably accurate graphs because then you can estimate things in your graphs And when you solve something algebraically, you can kind of test your solution. You'll see what I mean as we go further in the course. Okay, so we have here y equals 9 and x is 4. So where's the line x equals 4? Anywhere you want to put it, as long as it's to the right of the x-axis or the y-axis. I'm just going to conveniently put it here. This is 5, that looks like maybe it's about 4, so you pretty much have consistent scales. And if that's easy to do, it's a good idea. Now, if these numbers, if it's 0, 500, and 4, 900, you're not going to want to have the same y scale as you have x scale. You're going to want this to be 900, this to be 500, and you put 4 wherever it's convenient. Okay? Well, anyhow, you do that, and now you label the point 4, 9. Okay? So what have I done? For this one, first thing I did, it's a graph, made horizontal and vertical lines for the points. And you want to label those lines so you know what you're looking at. Because now you can, at a glance, see what's going on the graph. It does you no good to do 10 units here and 10 units here if you don't know this. And if you know this, you don't need 10 units there and 10 units there. Okay? If you want 10 units there now, well, you know this is 4, cut it in half, there's 2, cut it in half, cut it in half. Now you know how big a unit is, and you can make as many units as you want to. And y'all do a pretty good job of making even units, consistent units. Okay? I haven't seen anything on any of your papers that indicates that you make some of the common mistakes that I've seen. I mean, I see people in pre-calculus who label their numbers backwards. Okay? He'll call this 9, 8, 7, 6, 5, 4, 3, 2, 1. I've seen this, and not just once. Okay? And nobody here is doing that. So, you know, you'll are doing okay. Okay. Do something about that finger. Maybe amputation and prosthetic, does that work? I think that'd be drastic. Okay. Stop holding my chalk the way I do. That would work. Okay. Anyhow, we're labeling. Uh-oh, now my thumb hurts. Excuse me, I really do have a problem here. Last semester, that thumb was popping and cracking from handwriting. So let me see. I guess I can hold the chalk like this. My writing won't be as meticulous and beautiful as usual. And I know you'll find that disappointing, but we're gonna have to live with it because between this thumb and this finger, something got a little bit haywire. Okay, so anyhow, let's make sure I've got everything on the board, everything on the screen, and I didn't, but there it is. Okay, so we've done this much, right? Make sense? What do we do next? Well, in this case, in any case, where we're given 2 points, whether it's this case or this case, or this case or this case, right? And both of these were given 2 points. So that's what we're going to do if we're given 2 points, okay? Sketch the fundamental triangle. What's a fundamental triangle? I don't know if I've used that term, but I think it's the most important triangle in mathematics. It's fundamental to calculus, okay? It also is a good exercise in understanding what's going on in the coordinate plane. So I'm a step ahead of where I should be. Before we sketch the fundamental triangle, we should really sketch the line. Okay, chalk goes there. Need a longer piece of chalk. Okay, sketch the line. So I've sketched the line. Remember, if you want to sketch a straight line, make sure you're on line with this and then just look at this point. If you look at this point, chances are you're going to go through it or close to it. Okay, if you're looking down here when you're moving up here, your line's going to get wobbly. That's okay, as long as it's not too wobbly. You understand it's supposed to be straight. But if you want to make it look halfway decent, I make a little wobble there, right? You do that. Okay, so you sketch the line. Then sketch the fundamental triangle. So you go from this point, right? And then you're going to have to go either up or down. This is the run. This is the rise. Okay. So we have a rise and a run. What I'm doing here, I'm going to label fundamental triangle. Okay. I label the run. I label the rise. I say what the run is. The run is from 0 to 4, right? That makes the run 4 minus 0, which is 4. You subtract the earlier coordinate from the later coordinate. Now, with the run, you're always going to subtract the bigger number from the smaller because you're always going to go to the right. Okay? The rise, from here to here, so we subtract this from this. Rise is 9 minus 5 equals 4. Okay? That means now label rise, run, and slope. Now we haven't labeled the slope, so we're going to just kind of slop that down over here. You're right, slope equals rise over run. Don't skip that step. Okay? You probably remember it from previous courses. How many people remember seeing that in previous courses? Rise and run. Okay? A lot of times in pre-calculus, I see people that don't, which is why I say write the dang thing down. If you keep writing it down whenever you do one of these problems, you're unlikely to forget it and unlikely to lose track of what these things mean. Okay? You get meaning from these pictures. Now you can follow formulas without understanding anything about the meaning. Okay? But if you only understand these formulas that you don't understand the meaning of, you won't know how to apply them as well. It's worth a little extra effort. It doesn't take a minute to do this. Once you practice a little bit, you just slop down a set of coordinates, put a point here, a point there, put a line through it, put some vertical lines, label them, horizontal lines, and then label all this. Might take you 2 minutes. It's worth the time. At least do it every time you draw a graph in this course. So it'll be something you know in your gut when you get into later courses. It'll serve you well. Okay, so anyhow, rise over run, which is 4/4, which equals 1. Now I let my slope come out here and I put a box around it. And as I think I've explained before, but we're doing this in all three of the support course, the pre-calculus course, as well as this course right now. And everybody in all those courses is having a little bit of trouble with it, which is disturbing. Because this is fundamental intermediate algebra, okay? That's not so disturbing here because this is an intermediate algebra course. It's not disturbing at all, okay? But in those courses, it is disturbing because you're supposed to know intermediate algebra before you go to pre-calculus, okay? Well, that's why you're here. Okay, so anyhow, I put the 1 here. And I put a box around it. So I'm gonna emphasize you put a box around the slope, and you don't write it out here, you don't write it down here, you don't write it over here, you put it right over this hypotenuse of this triangle. And of course, you kind of emphasize that hypotenuse, okay? Now, when you're trying to work out the problem, you don't have to look for the word slope, you don't have to look for rise over run, you don't have to look for the 4/4, which you might have written anywhere, but I recommend you write it kind of close to the graph so that it ends up here, okay? Now you know what to look for. When you're doing something else with the problem, you got to remind yourself what the slope is. You don't have to go back and read a paragraph. You don't have to search the page. You look at your graph and you immediately know where to look and where to find your slope. You also write out the way you got the slope. And you write your run and your rise. So you have everything you need there to debug it if you screwed up. You see every bit of what you did to get the slope. Okay? So if things don't work out when you check the problem as you need to do, you go back and check out all the details. Now, you know your work, you know that, oh, geez, yeah, I often get the wrong sign on the slope, on the rise, okay? So check out if the rise is really positive. Stuff like that. Okay. There's a procedure. It's going to continue a little bit. So 6, you have a point and a slope at this point, okay? So I'll say now you have a point and a slope. So you plug into y equals mx plus b, an x, a y, and an m. If you plug in an x, a y, and an m, the only thing that you don't know is b, and you have a very simple equation that you can solve for b. Okay, so we do that. Now, where am I going to do that? I'll do it over here. So you have y equals mx plus b, m equals 1, x equals 4, y equals 9. You get 9 equals 1 times 4 plus b. Did you get us back there? Okay, which means 9 equals 4 plus b. Subtract 4 from both sides. Remember, put an equal sign there. I don't like a -4 and -4 without an equal sign. And you shouldn't like it either, even though that's what everybody tells you to do. Okay? I think it doesn't take much to write the equal sign and to understand now you're adding an equation to an equation. Okay? And that's useful to know. Other people might have a different opinion. Help it if they're wrong. Well, somebody is. Okay, so now b equals 5, right? Now you write y equals mx. Filling in m and b. So, well, here, okay, now we got y equals mx plus b. And now what do we have? Well, y equals 1x plus 5. Or just y equals x plus 5. Okay. Now I'll comment. In this case, you were given the y-intercept. So you really didn't need to do this. You already knew b was 5. Okay. But if you forget that, this procedure will get you there. And this procedure will do this problem for you as well. Okay. And it includes what you do with this problem. Is what you do now. Okay. For this problem, you're given the slope and a point. Well, if you're given a slope and a point, you can cut right to here. You don't have to do any of this, although you should do the sketch and label things. Okay. But after you've done the sketch and label everything, you can't really do step 5. Because you don't yet know what the y-intercept is. You don't yet have 2 points. Okay. So what you do is you do steps 1 through 3 and skip step 6. So I'm going to just kind of make a note of that here and then we'll do it. Okay, for the second problem, steps 1 through 3. And skip step 6. Okay. Let's see how that works. Okay, so you're given slope -2 and the point 7, -712. Well, you draw your graph. You label a point. You're going to need x equals -7 to locate this point, right? And then you're going to need y equals 12. Now you can label the point -712. Now you know your slope is going to be -2. Okay, well, you don't know exactly what to do with that, except you know, if you move to the right, then you're gonna have to move down twice as far, don't you? Because your rise is gonna be twice as big as your run, and it's gonna be negative. Well, we can actually do that. From x equals -7 to x equals 0, your run is 7, right? So I can kind of do this. I can say, okay, helps you to locate where your point is. This is more or less optional, okay? But if the run is 7, then your rise has to be -14, right? So it's not a bad idea to do this if you can. So that you know your line should go through these 2 points. Now, you don't have to do this. You can draw the line anywhere as long as it's decreasing. Okay. Matter of fact, maybe you don't even bother drawing the x-axis. Well, let's see how that works. But okay, now skip to step 6. Because we've done steps 1, 2, and 3. In sketching the line, I used a fundamental kind, but you don't have to do that. You sketch any line, but try to make it as realistic as you can. And OpenMath tells you how to do that. Okay. You don't have to do what I just did here. So this stuff in blue is optional. Okay. Just draw a line. Then we skip to step 6. And we say that, okay, you know, m is -2, x is -7, y equals 2. All this is given, isn't it? So now we go to step 7. Y equals mx plus b, 12 equals what? Sorry, -2 times -7 plus b. Okay. And you end up with, actually, easy to solve, you don't have any fraction. B equals, yeah, 12 minus 14, which is -2. Right? Well, my -14 was exaggerated here. I didn't get a good line. Okay. I should have only gone down 14. I started at 12. I should have gone down to here, shouldn't I? So now maybe we want to correct our graph. You know, maybe we draw everything real light. And understand that we might have to modify the shape of our graph. Because now we know the y-intercept. So we can put the y-intercept in. So I'm going to take this rise equals 14 thing in this. And this point here, but actually arrived at -14. Only takes me down to here. And here is the correct line. I'm going to leave the incorrect line there, but I'll show you how you cross it. I'll just put a little wavy line through it. Okay. So that was my first attempt at the line, but now here is my correct line. Okay. So this one is screwed up. It's the correct line. Make sense? Now I could write a step 8, go ahead and write your equation. Okay. Well, actually, that's what step 7 says. Actually, step 6, plug in. I should write here. Solve for B. Because that's part of step 7. Then we plug in and we get this. So we're still in step 6 here. Now step 7. Got y equals mx plus b. Now we know b and we know m. Okay. And then there's always the check step. If we plug in -7 for x and 12 for y, we get 12 equals -2 times 7 minus 2. -2 times -7 is 14. 14 minus 2 is 12. Now that's a step you always want to do so you know whether you got it right or not. If you don't have it right, well, what do you have? You have a picture. Well, here's a picture. Okay? Where you can see the meaning of everything it did and see what you might have done wrong. Okay? All right. Now, I'm not going to work this out because a couple of things I want to talk about. The line that contains these points. Two points. So we just follow this procedure. Okay. So for this one, do steps 1 through 7 with these points. I'll note that these steps work for any situation where you've got 2 points, a point and a slope. Okay. Y-intercept, 2 points, a point and a slope. If one of the points is the y-intercept like it was here, you really don't have to solve for b because you already know what it is, but sometimes people forget, and if you do it, it still comes out. B is going to equal y-intercept, right? Okay. So with some variations, if you always follow this procedure and skip what can be skipped, like at this point, once you got the rise, run, and slope, you're really done because you know the slope. If you know that this is a y-intercept, you can write your equation right now. Okay. So I would write down those steps. I think many of you have. And if you haven't, just go to the video, pull it up right at the, near the end. And, here we have 7-step procedure. How we would use it for the second equation and for the first problem, and for the third problem is do it. Okay. And if you practice doing that, get used to the picture as well, and think about what the formulas are telling you. Formulas are telling you the same thing. You can solve it using the formulas without drawing the pictures. Okay. Right now, I think you want to follow the procedure and do the pictures, and then take the formulas and see if they give you the same thing. That way, you'll know a lot about equations with lines. Okay. Okay, now, a couple other things I want to talk about. Didn't want to spend the whole time on that, but this is so important that it was worth. Well, I appear not to order what I just did. The equation of the line parallel to the line through a given point. If it's parallel, it has the same slope. And through this point, we'll have a slope of -2, same slope. And going through the point -3, -6, we'll just go to step 6 and do what step 6 said. Write out y is mx plus b. M is -2. X and y are -3 and 6, and here are arrows showing that. This gives us an equation that we easily solve for b. We get b equals -12, and there it is. Okay, so if we come over to our graph, now this graph is getting kind of cluttered up, but we have the x equals -3 line here. We can sketch the y equals -12 line. Here, and that all fits. And there's -6, there's -12, looks about right. Here's our point, -3, -6. I didn't have room to label it, but it'll be worth you writing it out and labeling it. So we have this point and this point. We can draw the line, and it comes out pretty much parallel to this line. For hand sketch, it's parallel enough to be plausible. Now, if we want a line perpendicular, let's say we want a line perpendicular to this y equals -2x minus 2 line. I can label that line. And that's this line. And this line is, and there's not a good place to label it. I'll label it, that's kind of small. That's y equals 2x minus 12. That's this line. Okay. And they're parallel. And this line you can verify goes through the point -3, -6. If I want a line perpendicular to another line, try line here, then it's going to have the negative reciprocal. Okay, what do we mean by negative reciprocal? Well, first of all, let's identify the slope. The slope is 2. So the negative reciprocal slope will be the reciprocal, which would be 1 over -2. It's a negative of that reciprocal. Well, that's like 1/2. You got two negatives, makes a positive. We got a slope of 1/2. So the slope of the line we want is 1/2. Then we know the point, we still have the point -3, -6. So we just do what we've always done, except we use a slope 1/2. We just do what we did over here. Instead of -2, our slope is 1/2. These 2 points, these 2 coordinates come out the same. There's your x equals -3 and your y equals -6. We do the arithmetic and we solve for b. Now, in doing the arithmetic, I've explicitly multiplied both sides by 2. I've written this side the -6. I've written this side the -1/2 times the 1/2 times -3 plus b with in parentheses, and then I put a 2 in front of each of those sets of parentheses and do what it says. 2 times -6 is -12. 2 times 1/2 times -3. Well, there it is. And I'm using this distributive law, 2 times this plus 2 times this. And we're going to have a 2b. People often leave off the 2b. They focus on this other thing. That they focus on the first term in the parentheses, but not the second. Don't walk in front of the camera. I'm recording. That's all right. You're not in the class that I'm recording for, so nobody will know who you are. Oh, you talked. Boy, you walk in front of the camera and you talked. Okay, I'll let you live this time, but hang in there, okay? It's all right. You're not in this class. Nobody knows who's supposed to be here. All right, nobody will identify you. And none of this is relevant to you anymore. Okay. So anyhow, we do this, and we get this equation. We solve for b. We get b equals 9/2, which is -4.5. And now we have the equation of our line perpendicular to this line to this point. Where does that line lie on this cluttered up graph over here? Well, again, here's our point, -3, -6. I guess I better go home. It's implicitly done because I've got a vertical line labeled and a horizontal line, so we know it's -3, -6. Okay, well, the y-intercept of that line is at -4.5. So where's not -4.5? Well, if this is 0 and this is 6, -4.5 might be about there. I think I have it, it should maybe be a little bit lower. But right there is the y-intercept. That's a point on the graph of this line. And -3, -6 is a point, so I can draw the line. Then I can expand this line and label it all the way out there. Y equals 1/2 x minus, I'll write 9/2. I use -4.5 because mixed numbers easier to put on a graph. -9/2. So I'm going to write it out this way. Okay, and that even looks kind of perpendicular. And it should, because the scales are relatively the same. Here's 7 on the x-axis. So 7 and 7 would be 14. 14 would be up here on the y-axis. So y equals 12 makes perfect sense. You should understand every bit of that. And if you don't, please ask me. Draw the picture, bring the picture, show me the picture, and ask me what you're missing. Okay? Get all that down, and you should be good with the assignment on parallel and perpendicular lines. Because we have a good step-by-step procedure for finding equations of straight lines, given 2 points, given the y-intercept and the slope, or given 1 point slope. Okay.